Somebody collected data on male heights in Chile during the years 2009 to 2010. They found that the average height was 170 centimeters, and the standard deviation for these heights was 6.28 centimeters. Heights are a measurement, and they are known to follow a normal distribution. So we can use a continuous random variable, x, to represent these heights, and then we can write that x follows a normal distribution with a mean of 170 and a standard deviation of 6.28. We know that the notation for the normal distribution has the mean and the standard deviation in these parentheses, so we can easily read that from the notation, or we can pull it from the wording of the problem. We need to find a z-score that corresponds to the height of a 16-year-old male who is reported to be 168 centimeters tall. Our variable value is this person's height, the 168 centimeters. We know we need to find a z-score, so we're going to use the formula where z is equal to x minus the mean divided by the standard deviation. Listing out the values for mu, sigma, and x, and then plugging them into our formula, we can find that z is equal to negative 0.3185. This z-score is negative. That tells us that this height is smaller than the average height, and it's negative by a small fraction, less than 1, less than a half even. So we know that this height is very close to the center. It's within 1 standard deviation below the mean. Even it's within a half a standard deviation below the mean. So this z-score tells us that the height, 168 centimeters, is within 1 standard deviation below the mean. Suppose we have a z-score for another male's height. This time we only know the z-score is 1.27. We don't know the actual height of this man, but we can find it. We know z, mu, and sigma. We can plug those into the formula that finds x. Using x equals mu plus z times sigma, we can find the height of this person. Plugging in the values for mu, z, and sigma, we can see that x, the height of the male, is 177.9756, which means the man's about 178 centimeters tall. Understanding how to translate between variable values and z-scores is an important idea, so hopefully this example helped illustrate how the two are related and how they're different.